morning. Let's continue with our second session, our exam paper session. We're taking a few examples. So I'm dealing with the March 2023. I know yesterday I wrote down April 2023. It's actually the March 2023 exam. So let's take this example. Okay. The question here is differentiate, find dy over dx. So what type of problem is this? Let's have a look. This is a problem where we have y is equal to inverse sine of f of x. How do I know it's inverse sine? Because of the negative 1 here. The negative 1 in trigonometry does not mean power negative 1. It means the inverse sine of the graph, okay, or arc sine. So it's that, or y is equal to arc sine f of x. Alright, so now the knowledge required here is the derivative dy over dx, which is going to be f prime x all over the square root of 1 minus f of x all squared. That is the formula for differentiating inverse sine or arc sine. It means the same thing. So in this case, what you need to do is identify the f of x part. So the function of x, and this is your f of x. So here, my f of x is equal to 1 minus x squared all over 1 plus x squared. You can see that. So now, this is f of x, which is a fraction. Now, if you look at the formula has f prime x in it. That means the derivative of f of x. So that means when I read this problem, I identify it as a fraction. That means I have a numerator and a denominator. So I'm calling my numerator u, denominator v. So f prime x means differentiate whatever function I have here. I have a fraction. The numerator has the variable x. The denominator also has the variable x. So therefore, in order to differentiate this, I will have to use the quotient rule. Okay, so that will be the quotient rule. So the quotient rule is, okay, let's write it down. The quotient rule is copy the denominator. I'm identifying my denominator as v there. Differentiate the numerator, u prime, minus copy the numerator, which is u, and differentiate the denominator v prime, all divided by v squared. Are clear with that? So the question is, what is u? My u is 1 minus x squared, and u prime, the derivative here will be 0 minus 2x. You clear with that? I'm just doing this in detail. Right, so now v, the denominator here is 1 plus x squared. So v prime, the derivative here will be 0 plus 2x. You're clear with that? So now everything is here. There's nothing that I've left out. We've got our f prime x. There's the here. Let's write it down in one step now. Let's put all this information together. So my dy over dx. So now here is the actual problem. Inverse sine f of x. The formula is f prime x. So f prime x is the quotient rule. You're clear with that? So the formula is copy the denominator. Copy the denominator, which is 1 plus x squared. Differentiate the numerator, u prime. There's your u prime here, which is going to be 0 minus 2x. Minus copy the numerator, which is 1 minus x squared. Differentiate the denominator here, v prime. My v prime is 0 plus 2x, which is 2x. So I'm here at the moment, all divided by the denominator squared. So that's going to be 1 plus x squared all squared. We're clear with that? So now I have just worked out the numerator of this formula here. Now it's divide by. So let me put my division line here. So that's divide by, and then I have the square root of 1 minus f of x all squared. So it's going to be the square root of 1 minus f of x. What is f of x? F of x is this part here. So there's my f of x here. You're clear with that? So my f of x is 1 minus x squared all over 1 plus x squared, and it is squared. And that is all. Simplification here according to this instruction. Determine dy over dx in each of the following cases. Simplification is not required. Therefore, you will get full marks at this stage. You're clear with that? Right. So that is method number 1. Okay, let's have a look at a different way of doing this here. Method number 2. So let's take the problem again. We have y is equal to inverse sine of 1 minus x squared all over 1 plus x squared. Now, if we want to get out of this inverse function, okay, get back to what it was originally, then I want to get rid of this negative one here. Okay, how do I do it? This is not an exponent negative 1. Remember, it means arc sine of negative 1. So what I will do is I will take sine of both sides. I'll go sine on the left, sine on the right. So I'm taking sine of both sides. So sine of the left, sine of the right. Okay, now what happens when you got sine and inverse sine? Those two functions basically cancel each other out, and we left with what's inside here. Okay, these two operations, I mean sine and inverse sine. So what's happening here is I end up with just 1 minus x squared all over 1 plus x squared, and there's my sine of y. You're clear with that? Right, so now this is no more an inverse trig problem. This is now an implicit differentiation problem. It's now implicit. Why am I saying implicit? Because we've got that variable y. So y is not the subject of the formula. We've got sine of y here. You can see that? So how will I differentiate this? I'm not going to write down dy over dx. I'll only write down dy over dx if y is the subject of the formula. But now I'm still differentiating with respect to x. So how do you do this? You write down d over dx on the left hand side, d over dx on the right hand side. You clear with that? So d over dx means I'm now differentiating the left hand side with respect to x, and I'm also differentiating the right hand side with respect to x. So d over dx of sine y. Let's deal with that. So d over dx of sine y. So this is implicit differentiation. So we're using the shortcut technique here. All you do is you differentiate sine y. And when you differentiate sine y, what do you get? You're going to get cos y. And then when you differentiate y, what do you get? 1. You're clear with that? Now remember, every time you differentiate the variable y, this is implicit. What do you multiply by? You multiply by dy over dx. So that is my left hand side sorted. Right hand side is obviously a fraction, so therefore it will be the quotient rule. You're clear with that? It's still the quotient rule. So the right hand side is the quotient rule. Copy the denominator, differentiate the numerator. 0 minus 2x minus copy the numerator. Sorry?
denominator.
Oh, sorry, my mistake, that's a plus then. Copy the denominator, which is 1 plus x squared, differentiate the numerator, minus 2x. Minus copy the numerator, which is 1 minus x squared, differentiate the denominator, which is going to be 0 plus 2x. All divided by the denominator, which is 1 plus x squared, all squared. Are you clear with that? So now all I have to do is make dy over dx the subject of the formula. So therefore, dy over dx is now going to equal to this part here, which I'm not simplifying, I'm leaving it as it is, because the question states do not simplify. I mean, simplification is not required. And this whole thing is divided by cos y. And at this stage, you deserve full marks. Why? Because you have followed the instruction. The instruction was find dy over dx. Simplification is not required. Now clear with that? Right. But now, if you want to go and you can make this equal to that. If you want to, for your own understanding, what do we know? We know that, this is just for extra information now. It's not really required to go and simplify further. The fact is, you must get full marks at this point here. But now let's see, this cos y. Okay, why do we have cos y here and why we don't have cos y there? You might be wondering. Okay, so let's go back to this part here. Sin y, what do we know? We know that sin y is equal to 1 minus x squared all over 1 plus x squared. Right. And this is not sin y, this is cos y. So we know that sin squared y plus cos squared y is equal to 1. So therefore, cos squared y is equal to 1 minus sin squared y. So cos y is equal to plus or minus the square root, but we're only taking the positive in this case. We do not have values to substitute. So I'm going to go the positive square root of 1 minus sin squared y. Okay, so it's acceptable to take the positive because we do not know which quadrant this problem is in. Okay, all right, we do not have any limits or to basically to indicate which quadrant we are dealing with. So we're taking the positive. Now I'm sure you can see what will happen. Cos y is equal to 1 minus sin squared y. But what is sin y? Sin y is 1 minus x squared all over 1 plus x squared. And there is your cos y. So if you wanted to, now you can go and replace cos y with this, and then you can see it's a perfect match now. Can you see that? So that's an example of differentiation of inverse trig functions. You can do both methods, it's up to you. It's your choice. Alright, then we'll deal with the next problem now.